As chair of the ESB, I'm very impressed and very proud of the people at Allenwood who decided to make a video about their station. This station is 40 years old. It's a long and distinguished history in the ESB. I invite you to look at this video. It's information about the station, about its history, and about the people that are in it. And I'm sure you will enjoy it. And again, I want to congratulate the station staff for their enterprise and for their interest in their station to make it worthwhile to make a video. And to thank them for inviting me as chairman of the company to say these few words of introduction.
The team wish you enjoyed this short video on electricity production in Allenwood. Allenwood is located 32 miles west of Dublin and 12 miles northwest of Naas in the Bog of Allen. The station was built in 1950 to use native fuel in the production of electricity. It consists of 4 boilers and 2 turbines with a total output of 40,000 kilowatts. These aerial shots with the grateful assistance of Paul Donnelly, DNR Auto Electric Naas, pilot and owner. You will see the complete cycle from the cutting of the turf to the electricity leaving the station. We're starting with the cutting of the turf, which is carried out by this machine called bagger. It cuts the 3-meter high bank using 2-meter wide blades. The turf is brought into the machine where it is macerated and compressed. It is then fed out along the spreader arm, which is 55 meters long, and dropped onto the ground to dry. The bagger, which weighs 50 tons, travels at 25 meters per hour. It cuts approximately 10 tons in that time. We are glad to say that this machine, which is the first in the process of electricity production in Allenwood, completes the cycle by using the end product of the station. It is powered by 4 150 horsepower electric motors. The turf is now left to dry naturally, and after a period, the windrower ploughs it into small rows to continue drying. After a few weeks, this machine puts it into bigger rolls and it is again allowed to dry. The collector is the final machine in the harvesting process. It travels at 100 meters per hour and stacks approximately 50 tons in that time. The turf is stored like this until prepared for delivery to the station. The first step in the delivery is the loading of the turf. The turf now starts on its 3-hour journey to the station. The track is laid directly under the bog, and because of this is easily damaged, so sections have to be replaced regularly. Lord Namona have their own crews to do this job. If damaged track is not replaced, wagons can be derailed. Lord Namona supply turf to Allenwood mainly from Timahoe and Ballydermot bogs, and occasionally small quantities are supplied by the Lodge and Muckland bogs. Some of these bogs are over 10 miles from the station. We wish to thank George Atley of Rathangan and all his staff on board Namona for their assistance with this section. When the wagons arrive at the station, the ESB staff take over with their own smaller locos. Each wagon is now weighed in the presence of ESB and Board Namona officials. Each wagon weighs approximately 6 tons. The wagons are lifted individually without their heavy bogies to the top of the building, where they are emptied into the bunker. Now that the turf is delivered, the next step in the process is the operation of the boiler. In this basic model, the main parts shown are the bunker, the grate at which the turf is burnt, and the water tubes. The turf is fed from the bunker through the turf shaft onto the grate. This grate is a steel conveyor belt made up of 18,000 individual links. The agitator loosens up the links to allow air to pass up through the grate for combustion purposes. Each boiler has 2 grates. This is an offload view of the grate from inside the boiler. The links have to be replaced on a regular basis because of the dense heat. The flow temperature is in the region of 1,500 degrees centigrade. This heat is used to convert water into steam. The water is pumped through the boiler tubes using a high-pressure pump. This whole boiler process of burning turf to produce steam is a form of energy conversion, which is a complex operation requiring continuous monitoring and control. To sum up this section, the boiler's sole purpose is to produce high-pressure steam for the turbine. The steam drives the turbine, which is directly connected to the generator. Included in this model are the turbine, generator, condenser and cooling tower. The turbine converts the energy of the steam into rotary motion and can be shown with this working model. This is an example of actual turbine blades. When the steam has given up its energy in the turbine, it is cooled and returned to the boiler as water to complete the cycle. Cooling water from the tower flows through the tube in the condenser, extracting the remaining heat from the steam. It then returns to the tower and gives up this heat to atmosphere. The water enters the tower through the center column and flows out through pipes to the sprayers. The design of the tower causes air to flow up through the timbers to cool the water falling from the sprayers. As the air rises in the tower, it carries water vapor with it. The tower is 286 feet high and is 205 feet in diameter at its base. To increase the efficiency of the cooling, the water is spread out from the sprayers and falling through the layers of timber is converted into the droplets, resulting in the maximum air-water contact. The water then returns to the condenser to complete the cycle. Next we show the generator. The generator actively produces the electricity and is directly driven by a turbine at a speed of 3,000 miles per minute. It consists of 3 windings inside of which a magnet is rotated, resulting in a 3-phase alternating voltage of 10,000 volts. This output is monitored in the electrical control room. All ESP power stations are connected to the national grid, and Allenwood is connected at Portlaoise and Maynooth. All switching and control of the station output is carried out by the control room operator. Voltage and power factor are some of the parameters which are constantly monitored. Station output at 10,000 volts is now converted to 110,000 volts in transformers. The transformer output is fed to the electrical compound where it is connected to the transmission lines by high-tension switchgear. That completes the story of electricity production in Allenwood. Allenwood won the safest ESP station award last year because all operations were carried out under strict safety regulations. Electricity is a wonderful and unique energy source. and is very safe when used correctly. Remember, safety rules are for your safety.